The WERF Endowment for Innovation and Applied Water Quality Research, honoring Paul L. Busch, was created to celebrate the spirit of innovation that he inspired in each of us. A member of WERF's first elected board and its third chairman, Paul recognized the need for research and the key role WERF could play in fostering innovation and application of new technologies.
WERF has been created to help assure the American people that we're going to spend our money wisely, but they want to be sure that every dollar spent on the environment gives an environmental benefit.
Paul always was trying to teach people to do things the right way, and he was always encouraging people, especially young people, to step up and try to change this business, try to make a quantum leap in the state of the art that we have.
The $100,000 Paul L. Busch Award is a very generous and prestigious honor awarded to an engineer or scientist recognizing innovation and its practical application. This year marks the 15th year the Paul L. Busch Award has been given. This year's winner will be joining a class of highly accomplished researchers and water experts. WERF is proud to announce that the 2015 Paul L. Busch Award goes to Mari Winkler.
The oceans. Over 70% of the planet is covered in water, and by volume, the oceans occupy 97% of the Earth's inhabitable space. In a single teaspoon of seawater, millions of the smallest organisms on Earth are actively cycling nutrients. Some of these organisms produce as much as 30% of the nitrogen gas that makes up the atmosphere and that we breathe every day. In this year's Paul L. Busch Award from the Water Environment Research Foundation, Dr. Mari Winkler from the University of Washington has proposed exciting new research to grow some of these marine organisms together and to greatly improve some of the freshwater processes in wastewater treatment.
In the past 20 years, microbiologists have discovered two very important microorganisms involved in the nitrogen cycle of the oceans in the oxygen minimum zones: anaerobic ammonium oxidizing bacteria, or anomox, and ammonium oxidizing archaea, or AOA.
About 10 years ago, we discovered that ammonia oxidation in the oceans is controlled by previously an enigmatic group of organisms, the archaea. And these organisms, now known as ammonia oxidizing archaea, control the oxidative elements of the nitrogen cycle in the ocean. In particular, those traits make them important in oxygen-depleted regions of the ocean, such as the oxygen minimum zones, where they interact directly with anomox organisms, providing the anomox organism with nitrite, which is then used for complete removal of reactive nitrogen as nitrogen gas.
So the basis of my proposal is to mimic the conditions of oxygen minimum zones and apply it in engineering terms.
I've worked on nitrogen removal processes using nitrification and denitrification since the 1970s. The recent ability of engineers to harness anomox metabolism with anomox granules is a major shift in the methods for nitrogen removal. The ability to use AOA and anomox may result in a dramatic reduction in capital cost, energy requirements, and greenhouse gas emissions associated with nitrogen removal.
I would like to make an improvement for wastewater treatment by taking inspiration from oceanography and using AOA and anomox. The problem with AOB is twofold. The first problem is if the oxygen concentration is too low, AOB reaction stops. If it's too high, then NOB grow into the system and snatch away the nitrite, which is the food source of anomox. The second problem is that if ammonia is too low, you need high oxygen in order to remove it with AOB. So you see the problem. If ammonia is low, you need to add oxygen. But if you add oxygen, you select for NOB. By using AOA, both problems can be solved. What's special about AOA is that they have a high affinity for oxygen and ammonia, and this makes it possible to run the treatment plant such as in the oxygen minimum zones in the oceans.
AOAs are usually not found in wastewater treatment plants, and the reason is that they're operated in a way which does not select for them. So in order to create conditions enabling Anamox and AOA growing together, the treatment plants have to operate it in a way that they biomimic the oceans in order to let them grow in wastewater treatment systems.
When I heard that I won the Busch Award, I couldn't quite believe it. It's such a great honor to have won this prestigious award, and I'm very thankful.